Okay, well, I can rewrite these equations in the form of a coefficient matrix and reduce the matrix, but what I ask people to do is just eliminate one of the variables between this equation and this equation, and then use the result down here, okay? Because we can then do the same thing here. So we just treat the first two equations and eliminate a variable. Now the variable that I want to choose to eliminate is I2. Okay, if we do this matrix reduction, it leads to this, which doesn't eliminate I2, the variable I want, just following standard algorithm. Now I could rearrange so that I2 becomes the first column and I1 becomes the second, then we would eliminate I2. But instead of doing that, it's easy enough to go ahead and eliminate I2 here, okay? So adding 6 times this equation to this equation pretty clearly gives me $18I1, right?
And it should be
And then
negative I3.
minus 6I3 equals negative 6 amps. Okay? Is that what we get?
Mm-hmm.
And of course we're going to get the same thing here. And that's going to be very useful. My favorite CD, oh well. Okay? So now I can combine this equation with this one. Okay?
Right.
Then eliminate either I1 or I3. I3 would be the easier. Just, subtract double this equation from this one, and I3 is going to go away. You go find I1, right? Over here, it's even easier. I take these equations. I already know I1.
Right.
Okay, 3/4 of an amp. Okay, so I can easily find I3, right?
Mm-hmm.
So, just an exercise in solving simultaneous equations, and it's something you already know how to do, this way or this way, okay? Now, in general, if you have a big network, you're just going to you put everything in a matrix and tell it to give you the row reduction, okay? Because you can do row reduction.
Right.
However, right now I want you to review what it is because I don't want you to be using it in a computer algebra system without knowing what it does. If you've got a huge network, you got 20 equations, and it's easy enough to write down that network if you're careful.
That'd
Okay?
take a long time to be careful with.
It wouldn't take a long time. If you're careful,
Right, if
you can
you're
write
careful,
the thing
yeah.
down. Now what I would do is I'd write it down 3 times.
Right.
One on Sunday, one on Tuesday, one on Friday, and then Saturday I'd compare them, okay? And I'd still find it screwed up. So you got to be careful, and there are all kinds of techniques you'd go to, and that's engineering stuff. You just got to have an algorithm that eliminates errors, okay? But once you have that, you just put that into the computer and make sure you don't screw it up, and press a button, and boom, there's your solution. Okay? Now, when we start replacing this with a capacitor, we're going to get differential equations. Okay? And it's going to get a little more complicated. You've got to get a system of differential equations, which is one of the justifications for including systems in that course. Okay? Unfortunately, our revised syllabus doesn't include systems. So next year I'm going to teach it anyway. Just the basic bare bones, 2 days on systems. Because it's so easy to introduce that to people who know the matrices and who understand second and third order equations, okay? Anyhow, so there I am admitting my crime in advance. If anybody wants to question what I did, I'm guilty. Assuming I actually do what I say I'm going to do, and I thumb my nose at the system, politely. Okay. It just doesn't fit with our physics course if we don't do that. And we're limited. You know, we got to do capacitors in parallel by magic. You don't end up with a tool that allows you to do any network. Okay, well, anyhow, so we solved this. So go ahead and solve both systems.